Hi guys, today I'm going to demonstrate the performance comparison between two algorithms that solve the closest pair of points problem. Algorithm 1 is brute force algorithm, algorithm 2 is divide and conquer. Here we can see the all code. After executing the all code, we can see the outputs. Um, Here in the brute force algorithm output, we can compare the empirical versus predicted runtimes with the brute force method. The red and the blue curves are almost overlapping, showing our predicted model fits well. Here, the time increases quadratically with input size, and we can see the divide and conquer output also. Um, Here also is the similar comparison, but for divide and conquer algorithm. Here, run times grows much slower than brute force. Um, and also, predictor line also matches empirical data closely, validating the O of and log n behavior. Um, and also the empirical comparison graph. Here, the direct side-by-side empirical runtime comparison of both algorithms. Brute force algorithm rapidly increases while divide and conquer algorithm grows much more slower. By n is equal to 32,500 data set, but brute force algorithm takes nearly 80 seconds, while divide and conquer algorithm takes just around 250 milliseconds. Here we can see the summary table also. Here we calculated scaling constants. Here we see the theoretical, empirical, and the predicted runtimes in the tabular form. We calculated the scaling constants. Here C1 is equal to 7.476 C for the brute force algorithm. C2 is equal to 3.631 for the divide and conquer algorithm. Um, implementation overview is both algorithms were implemented in Python. Um, we generated random 2D points for various point sizes ranging from 10,000 to 32,500. For each input size, we ran the algorithm multiple times to obtain average empirical runtime. We also calculated the theoretical runtime O of n square for the brute force, O of n log n for the divide and conquer algorithm. A constant C was estimated to scale theoretical times and generate predicted runtimes. Conclusion: here comes to conclusion. Divide and conquer algorithm is significantly more efficient and scale better than brute force algorithm. Our empirical findings strongly align with the theoretical complexities. This validates the importance of algorithmic design in solving large-scale computational problems. That's it, guys. Thank you.